Our MicroRacer dataset is included with this package, and it's a series of IGES files. So I'm going to go into the folder and just select all of the data files. The import options is displayed. There are many options available to you, and generally speaking, the default settings is a good start for loading your data. I do want to mention the top switch called Keep Surface Data is something to remember. VRED always uses tessellated data. The tessellated data is fast, efficient, and does a great job representing a shape. You can always see the tessellated form by using the wireframe mode when selecting. One of the many things that sets VRED apart from most tools is that VRED also has the ability to work directly with the NURBS or math definition of the geometry directly. Design and engineering tools like Alias and Inventor create most geometry in the math form. Because VRED can utilize the math representation and rendering, this option keeps the surface data available. If you don't want the original surface math data to be maintained, uncheck this option. We clicked OK, and the translation process started. So if we look over in our scene graph, not only do we have the standard cameras that we've had before and the environment, but all of the IGES files have been added to the scene graph. By clicking on any of the IGES files directly, the file itself is being selected, but in this case here it's a little hard to see. By selecting the bumper, we're going to get a better view of the selected geometry. The bounding box gives us an envelope of the selected geometry. Switching to wireframe not only shows us the details of the selected geometry, but shows us the tessellation of the geometry as well. To navigate in the scene, use your middle mouse button to pan, your left mouse button to rotate, and use your right mouse button to zoom. Now that we've zoomed in a bit, you have a better understanding of the tessellation. In rounded areas and high curvature areas, you're going to have a lot more triangles than in flatter or smoother areas. To select an object in the screen, you hold the Shift key down and then you click with your left mouse button. To add to a selection, we're going to keep on holding the Shift key down, but we're going to add the Control key, and then we're going to select the objects. If we look over into our scene graph, we're going to notice that these items that we selected in the screen have been selected in the scene graph itself. Notice that instead of selecting the whole file, it's actually selected the component of the file. So therefore, we can use the scene graph to also select individual components. To deselect everything, I'm going to first click into the screen, and then I'm going to hold the Control-Shift key down and hit the A key to unselect everything. I can easily see the full render view window by hiding both my assets and my scene. Both windows can easily be turned back on by accessing them in the Quick Access bar. Our next step with working with the geometry is to optimize it. I've selected the black.igis file. I'm going to right-click in the Scene Graph window and choose Edit, and then Show Optimize Module. I'm going to add in the Flush Transformation nodes as well as the Cleanup Group nodes. And now I'm going to optimize the geometry. We're now going to select the rest of the geometry and do the same optimization process. I find having a starting viewpoint is helpful, and therefore I'm going to create a camera view that I can easily switch to. The simple UI makes this extremely easy. After selecting the Camera tab, click the Capture button to set the camera viewport. At any time now, I can go to that camera view by clicking the Viewport button. For example, I know I'll be working at the back end of the car. I can tumble around to the back and then click the Capture button to save that view. A saved viewport can easily be updated or deleted. So at any time now, I can click on the Viewport or the Viewport 1 button to go to the front end or the back end of the vehicle. For this model, the bottom of the body is at the origin. We are going to move the environment down so that the tires are just into the ground plane. We'll use the transform tool that's located up in the icon bar to do this motion. We started this transform by having the environment selected. That allows us to use this manipulator to move the environment into the position that we like. VRED uses red, green, and blue to represent X, Y, and Z. Since we need to move this environment up and down, we're going to use the Z direction, or the blue. In visualization systems, we typically like to have the cars just a little bit below the ground surface. So we'll keep on adjusting this manipulator until we have the environment positioned as desired. To hide the wireframe, click the wireframe button. The environment is still selected, but not shown in the render window. To deselect everything, click into the scene space and do Ctrl-Shift-A.